Today is Sunday, January 22nd, 3 days after the lab's completion. Upon arriving home on the first day, I positioned the Chem wipe on the top of the vial so that the system could breathe and water could evaporate. After sitting stationary for 3 days, there is no visible crystal growth. At this point in time, there could be incredibly small crystals forming, or the ions may not have collided in the right way for the crystal to begin growing yet. One possibility that could explain this phenomenon is that an insignificant amount of water may have evaporated from the vial, preventing the concentration of alum from increasing past its saturation point and preventing solid alum from crystallizing in the vial. To make alum crystals, we first needed a source of a required element, aluminum. To supply this, we dissolved a gram of aluminum foil in potassium hydroxide solution. This released aluminum ions into the solution, which immediately bound to other hydroxide ions in the solution from the potassium hydroxide. A solution containing potassium ions and aluminate ions was ultimately created. After the foil's dissolution, these ions were also accompanied by large solid impurities, which had to be filtered out. These impurities were removed via a few rounds of vacuum filtration. After filtration was completed, the resulting solution was clear, colorless, and ready to have sulfuric acid added. Once the initial portion of sulfuric acid was poured into the solution, a puffy, thick, white alum precipitate formed. This substance formed due to the addition of positive H ions from the sulfuric acid. These ions accepted the negative charge on the aluminate ions, causing the aluminate ions to become solid aluminum hydroxide. When the second portion of the sulfuric acid was added, the solution containing the precipitate was gently heated to aid in the dissolution of the precipitate. The applied heat increased the kinetic energy of the molecules in the beaker and caused the liquid particles to hit the solid molecules more frequently and more violently. This caused the transfer of energy to the thick precipitate, and the precipitate dissolved to leave the following ions in the solution: aluminum 3+, K+, and sulfate. After this, the once again clear colorless solution was submerged in an ice bath to cool its temperature. The decrease in temperature slowed the motions of the particles in the solution and decreased their kinetic energy, allowing intermolecular forces to dominate and the alum to crystallize. These crystals were then separated from the liquid around them through vacuum filtration and were washed with a mixture of cold ethanol and water. This specific fluid was chosen to wash the crystals because it prevented the greatest amount of unintentional dissolution. A mass of the solid alum was weighed and added to 40 milliliters of water to create a saturated solution to put into the vials for crystallization. It is important that the solution be saturated because a high concentration of alum particles increases the likelihood that the alum molecules will collide and ultimately crystallize. Finally, to allow the crystals to form, the saturated solution was filtered into a small vial to ensure that no undissolved salt was added, and was topped with the Chem wipe to ensure that ideal conditions for crystallization were maintained. Crystals were formed when a process known as nucleation occurs. Nucleation is a slow process, either spontaneous or induced by the vibration of particles, and is the basis of crystallization. As the water evaporates from the vial, nucleation will slowly occur, and a crystal will be formed. To grow crystals of table salt, I would follow a similar procedure. First, I would measure enough table salt to create a saturated solution. I would calculate how much salt to add by finding a table that displays the solubilities of salt in water at different temperatures. For example, at 25 degrees Celsius, 384 milligrams of salt can be dissolved in 1 milliliter of water. I would then heat the water so that the salt would become more soluble, and I would oversaturate the solution at 25 degrees Celsius. Once the water is heated and the salt is completely dissolved in the water, I would pour some of the water into a vial and allow it to cool with the permeable sheet on top, such as a Chem wipe. As the solution cools and the water evaporates, the crystals should begin forming on the surfaces of the vial. Another method that can be used to grow a crystal is solvent diffusion. In this method, a dense, concentrated solution is poured into a sample tube. Then, a less dense solution is carefully dripped down the side of the tube to form a separate layer on top. Large crystals form slowly at the boundary where the solvents slowly diffuse.